Shika, Noto Peninsula, Japan. Seasonal winds from Siberia cause turbulence in the Sea of Japan in winter. Slanting winds and snowfall that make you so cold that your body almost breaks. Under an occasionally glaring midsummer sun, a total of 2 million men gathered for the construction of Unit Number 2 for the Shika nuclear power plant, Hokuriku Electric Power Company. It would become one of the most advanced ABWR plants in the world. Mastercraft, as free of error as a craftsman's skill. It is an artisan's art comparable to Wajima lacquerware, a traditional craft of Noto involving 124 processes. Just as Wajima lacquerware has been enhanced by a division of work to produce eminent, unrivaled lacquerware, Unit Number 2 for the Shika nuclear power plant, Hokuriku Electric Power Company, represents a crystallization of the expertise of Hitachi Group technical personnel. Noto Peninsula, Hokuriku Region, Japan. The town of Shikamachi on the western coast of the beautiful peninsula is rich in preserved nature and the site of numerous tales of history. Along the shoreline of Sotora, on the western side of the peninsula, which has been turned into a masculine form of beauty by the violent and raging sea, is Unit Number 2 of the Shika nuclear power plant. The sea spreads before your eyes. A design that leaves the unchanged shoreline is the first attempt in a design case of any nuclear power plant construction. Thus, this plant has become something that gives the greatest possible consideration to environmental harmony. The plant has a rated output of 1,358,000 kilowatts. Shika Unit Number 2 is the world's fourth ABWR plant intended to lead the nuclear electric power generation for the 21st century. One main feature of the plant is the use of a reactor internal pump system. The recirculation pump designed to circulate coolant in the reactor pressure vessel is installed directly on the bottom of the pressure vessel. This has made it unnecessary to provide large diameter piping previously installed outside conventional pressure vessels, thus achieving higher efficiency and safety. Moreover, using an advanced control rod drive system powered by an electric motor has made it possible to precisely control the control rods. In an emergency, a hydraulic drive system quickly inserts the control rods. Also, the reactor containment vessel consists of reinforced concrete walls of 2 meters thick and a steel liner of 6 millimeters thick, thus making it compact. These systems and equipment have been introduced to dramatically increase safety, reliability, and operability compared to conventional versions. Construction work procedures were carefully prepared by conducting CAD simulations, taking full advantage of the latest IT technology. One should be proud of the fact that Hitachi Limited is the first to attempt building an ABWR nuclear power plant whilst undertaking all processes, from design, manufacturing, construction, and testing alone. This was a matter of pride for Hitachi, the technical corporation. March 27th, 2001, a lucky day in Buddhist tradition. The Shika construction office, Hitachi Limited, was established. At that point, the project shifted from excavation for buildings and other aspects of civil engineering to actual plant construction. Lifting and installing huge piping for circulating water. The team's work has begun. On this piping will be built a turbine building. Hitachi Limited, Hitachi, Ibaraki Prefecture, Japan. This is the company that manufactures the main equipment and components to be used for Shika Unit Number 2. Objects as large as dozens of meters in overall length and even as small as tiny screws all represent the crystallization of Hitachi's technology. The basics of welding, polishing, and other areas of fine monozukuri, creative manufacturing, that do not permit any errors of even a thousandth of a millimeter, lie in the feel of the fingers that cannot be imitated, even by a computer, and the eyes of an artisan that do not overlook even a moment's chance. Customers have just completed an inspection of the bedrock that will support the foundation of the reactor building. At about the same time, components of the equipment arrived from the factory. It was then that assembly of the RCCV line for the reactor containment vessel began. By big Ibis, a large crawler crane. It moves freely around on the worksite while lifting up to 930 tons. It has a 140-meter boom that extends just like a wing. Big Ibis was so named given the fact that this place used to be home to the Japanese crested ibis. Without any difficulty, it lifts even a central mat module, weighing as much as 600 tons. Big Ibis is the star and the leader of the worksite. However, the construction of an ABWR plant entails as many as hundreds of processes. There you find the results of numerous professionals. Teamwork involving many artisans supports the worksite, which cannot be achieved by stars alone. It does not matter whether there are people who make names for themselves. Wajima, Noto Peninsula, Japan. This is home to lacquerware, supported by a history of nearly 6 centuries. Wajima Nuri lacquerware, an important intangible cultural asset, has been acclaimed as sturdy and elegant for its beauty and strength. The reason why Wajima Nuri lacquerware has become a representative craft of Japan is that it has always embodied an artisan's spirit, eager to create excellent things and pass them on to later generations, along with its supporting division of work. Kiji Zakuri, base preparation, Nuno Kisei, coating, Jizuke, preparation. Shitagi togi, base grinding. Nakanuri, middle coat. Konakatogi, minor middle grinding. Uanori, top coat. And kashoku, decoration. The 124 processes are called the 6 Wajima Jobs, with a separate group of specialist artisans undertaking each process. This is because each artisan can enhance individual skills by pursuing a single task. Each artisan then passes on their work, in which much pride is taken, to the artisan for the next process. Good work triggers the birth of the next round of good work. This is a beautiful chain that represents silent teamwork. One summer day, simulating the experience of predicting danger was organized. What is most feared on the construction worksite is human error. Even when those possessing the greatest experience are at work, the slightest carelessness might lead to an accident. There is no such word as excessive in safety checks. We wish you safety. In your hometowns, your families are waiting for you to return safe and sound. In this season, the rice has a yellow-gold tint. The sun sets, and the lead-colored winter will soon arrive. The key to the construction of a nuclear power plant is welding. Even though automatic welding has made much progress up to now, it is no easy task to weld piping on site at as many as 30,000 points. The true workmanship of welding artisans is tested in a vacuum inspection of the RCCV liner welds. A heavy responsibility lies on the shoulders of each and every artisan. In January 2002, after the New Year's holidays, the RCCV lower liner was lifted and installed. The lift was performed by team play between above-ground workers and the crane operator. A huge object weighing as much as 600 tons is finally adjusted by means of human voices and human hands. A pedestal is something that secures the support of the reactor pressure vessel. Safety walls are built one by one. Still, it is a long way off until this enclosure will be filled by the reactor pressure vessel. At the Futo works at Hitachi, Ibaraki Prefecture, a turbine condenser was being manufactured. About 60,000 cooling tubes are inserted. Cooling tubes made of 18-meter-long titanium are inserted by teams of 5 workers each, as if passing the baton in a relay race. The worksite for design, manufacturing, and construction. The best nuclear power plant is realized by linkage work. The manufacture of the equipment is progressing very steadily. The assembled lower and upper body sections of the condenser make a half tour of the Japanese archipelago northward, starting from the Pacific Ocean to the Sea of Japan. The lower body section of the condenser has arrived. Slinging has been an artisan's task that depends on experience and intuition. However, adjusting the wires for large structures weighing as much as hundreds of tons takes a long time. Should the balance be lost, a major accident may result. This concern prompted the development of a lifted load monitoring system. A wireless load cell measures all loads at the lift points and sends all related information to a computer. All that remains is to punch in the numbers before a secure balance can be ensured. The time has been reduced to 1/4 of the original time. Above all, this system ensures a higher degree of safety. The lift is conducted on a lucky Buddhist day, Taiyan, to ensure luck, just in case. Even though leading-edge technology is now used, the artisans strictly observe rules that date back to ancient Japan. As construction progresses, there is little room for people, machines, or the crane to move. Lifting work with hardly any clearance increases day by day. In June 2002, the construction project for Shika Unit No. 2 of Hokuriku Electric Power was 45% complete. Upon installation of the upper body section of the condenser, lift and installation of the RCCV upper liner was completed. For the liner, the upper and lower sections are welded, thus forming one body. The town of Shika enjoys its autumn festival. With light musical accompaniments, lion dolls and actors disguised as mountain spirits dance around. Big Ibis is undergoing an annual inspection. An inspector walks all the way out to the tip of the boom, tens of meters above ground level, to check for any anomalies. The crane is a member of the team. The morning begins with snow removal. This is perhaps another charm of the Hokuriku region. Toward the end of winter, large objects were lifted and installed one after another. Main control room, moisture separator heater, and dry well module. The drywell module, on which large numbers of pipes and structures are assembled, entails complex work for installation due to its structure. It thus requires careful work adjustment. To ensure reliability at all times is perhaps what an artisan is supposed to do. Workers engage in a tug of war to warm up in winter and strengthen their solidarity. Spring is just around the corner. The generator stator has arrived. The turbine building is already covered with a roof truss steel frame. It is becoming difficult to lift and install the structure by using big Ibis. A body as huge as a steam locomotive is moved to its specified position with the help of a special-purpose hydraulic device. Linear movement is made with extreme caution. Moving as slowly as a tortoise. Directional changes are made using a jack. Moving only 50 meters took 8 hours. Kure, Hiroshima Prefecture, Japan. Reactor pressure vessels, the heart of nuclear power generation, are manufactured here at the Kure works. Top-level materials that can withstand high temperature, high pressure, radiation, and corrosion are used to manufacture the pressure vessels by employing leading-edge welding technology. The casing welding of the internal pump, a most important feature of an ABWR, is conducted with caution while checking the torch tip on a monitor. When inspection at the works is completed, the day comes when personnel see off their children, whom they have brought up with much care, and of whom they are also proud. This represents the crystallization of technology produced through 3 years of hard work. The equipment is now leaving the Seto Inland Sea for the Sea of Japan. Four days later, in a downpour, the reactor pressure vessel has reached the inclined wharf. The reactor pressure vessel, which is the heaviest piece of equipment, is unloaded from the ship by using a large 1,600-ton marine crane. This has greatly shortened the time required. The pressure vessel slowly crosses the prefectural road. The vessel is lifted and installed as follows. The procedure begins with the pressure vessel being carried in and ends with lift and installation. All preparations are made based on CG-based simulation. September 18th, 2003, lift and installation of the reactor pressure vessel began. The reactor pressure vessel is slowly sucked into the containment vessel. The reactor pressure vessel is placed on the base. However, the crucial moment is yet to come. When comparing this to the process of Wajima Nuri lacquerware, you could say that the middle coat is barely complete. Men are working silently, bent over and twisted in a dark structure. Men are working covered all over with oil in a hot and humid building. Such men are building the world's highest level nuclear power plant. Around the same time as when the pressure vessel was installed, one piece of equipment after another was carried into the main control room, which had previously been empty. This will become the cockpit for Shika Unit Number 2. In early spring of 2004, the low-pressure rotor was installed. Preparations were steadily made for power generation in the turbine building. In September, the emergency core cooling system passed a water flooding inspection. Adjustment of the advanced control rod drive system was completed, thus making the reactor pressure vessel ready for pressure and leakage-proof inspection. The pressure began to be raised. Pressure was applied equal to 1.25 times the design pressure. The pressure was held at 10.8 megapascals. When the rise in pressure was complete, a thorough inspection, witnessed by an inspector from administration, was conducted of the piping, equipment, and welds. The moment has arrived to test the results of the accumulated work and reaffirm the confidence and pride of the personnel involved. The brand new completed plant is very beautiful. However, its true beauty will be revealed when the plant begins running. It is truly beautiful when the reactor generates steam that passes through the piping and goes into the turbine, and then produces rotary energy to generate electricity. Beauty is when something is used generously in its true configuration. April 26, 2005, Shika Unit Number 2 was ready for fuel loading. The reactor core was being slowly and securely loaded with fuel assemblies. May 26th. The plant is now complete with 872 fuel assemblies. The control rods are pulled out and the reactor is lit with the first light of Shika Unit Number 2. Steam generated by the reactor is sent to the turbine, which runs as fast as 1,800 RPM. The turbine has a grand manner, as quiet as a mountain. Its output is increased in steps toward the rated output of 1,358,000 kilowatts. Startup tests are conducted by repeating severe tests and inspections to ensure safe and stable runs. Finally, the output reaches 100%. October 9th, 2005, Unit Number 2 at the Shika Nuclear Power Plant, Hokuriku Electric Power Company, has reached its full power. A little more than 1,800 days have passed since the construction work began. The site for Shika Unit Number 2, which continues to generate electricity, is now devoid of big Ibis. A total of 2 million artisans and engineers who exhibited their full skills are no longer there. Scaffolding men, plumbers, crane operators, welders. These men exhibited their combined skills to build a nuclear power plant of which they can be proud of all over the world. I welded the pressure vessel. I installed the cooling pipes for the condenser. I changed the direction for the power generator. Men who assembled the reinforcing bars, men who did the slinging, men who supervised the work site. Even though they never appeared to the public, they took full advantage of their steel-like bodies and wisdom and left their mark, which deserves to be called the work of artisans. Just like Wajima Jobs, where refined skills gave birth to a next round of skills and built a tradition of 6 centuries. good work is surely inherited by the next generation. The proof of such a fact continues to be provided by the ABWR of Shika Unit Number 2.